Kia ora koutou, here's video 2, going through questions 5 to 11 in Mrs. Roberts' mini practice worksheet. So some of these solving ones we have to think a little bit about, but the first question is a simplify one with powers, which is not too bad. So I'll just do them down here. Let's see. Where are we? Okay, so question 5. We've got 3x cubed y squared to the power of 4. Now, if we have to, we could write that out just like this to get our brains going about what's happening. But by this point in the topic, you shouldn't really have to do that. But we're timesing this by itself 4 times. So that means that the 3, we just do 3 to the power of 4. So it's 3 times 3 times 3 times 3. So that's 81. And then we have x cubed times x cubed and so on. So remember, our rule is that when we're doing a power to a power, it's just going to be multiplying those powers together. X to the power of 12 times y to the power of 8. If you can't do that one easily by now, it's time we did some recap on Dr. Frost again on year 9 and 10 algebraic expressions. So let me know if you do need that, if you're in my class. Right, the next one, then we get on to solving. And so we're starting with some linear equations. So here our job is to figure out what value of x makes that a true statement. And the big idea when we're working with linear equations is to always do the same operation to both sides of the equation. So think of it as like a coat hanger in the wardrobe, and you've got to keep it in balance, right? So we've got to add 4 onto both sides. I know for most of you this now is starting to feel really easy, which is great. And here we've got half of x is equal to 14. So to undo timesing by a half, we times both sides by 2. So we get x is equal to 28, right? So we're timesing by 2 here. Okay, question 7. 14 plus x is equal to x over 3. Now, there are a couple of ways to do this. I think the best way is to think about that x over 3 as 1/3 of x and just not to freak out when we see a fraction, right? So x divided by 3 is the same as 1/3 of x. This x is 1 whole x. So we're going to do what we always do when we have numbers, x on both sides of the equation. So this is often called x on both sides because x is on both sides, right? So I've got a year 9 video or a year 10 video on that if you can't do this one. But in this case, we're going to get the numbers to one side and the x's to the other side. So I am going to start by subtracting 14 from both sides. So we're going to have x is equal to 1/3 x, take away 14. And now here I've got a whole x and here I've got 1/3 of x. So over here, that's going to leave me with 2/3 x is equal to negative 14. Now that's the same as 2x divided by 3 equals negative 14. And I know a lot of you are really comfortable when you see it written like this, but less comfortable when you see it written like this. It's exactly the same thing. We're going to times both sides by 3, and we get 2x is equal to negative 42. Lastly, we divide by 2, and we get x is equal to negative 21. Right, so that's one way to do that question. I'm going to show you another way now. So I just want you to be really confident that you can choose, right? Here, I said that I was going to subtract the 14 from both sides, and so we ended up with x equals blah, blah, blah. But I could have done it the other way around. I could have left the 14. I'm going to do it that way now to show you that. So we'd go 14 plus x is equal to 1/3 x. 14 is equal to 1/3 x minus x. So 14 is equal to negative 2/3 of x. And then we have 42 is equal to negative 2x. And then negative, I'm running out of space. Sorry, guys. And then we get negative 21 is equal to x. Okay, so 2 different, very slightly different ways to do that one. But I know that sometimes when you start doing x on both sides, you kind of get really used to always keeping the x on the left-hand side or always keeping the numbers on the left-hand side. And I want you to start to get a little bit more flexible with that. What have we got next? Question 8. Okay, question 8 is another x on both sides. It's actually, I think, a little bit easier. So 21x take away 18 is equal to 8x plus 21. I'm going to do x's here and I'm going to do numbers here. So subtracting 8x gives me 13x minus 18 equals 21. Then we add 18 to both sides. 13x equals 39. X is equal to 3. Question 9. X squared minus 25 is equal to 0. So this is a different kind of equation, right? This is a quadratic. And when you see quadratics this year, I want you to think that we're always trying to write them as something times something is equal to 0. And then we use the property that 0 times anything is 0. And we call that factorizing, right? And we've done that heaps. So in here, this is a difference of two squares pattern. Difference of two squares. Because we've got x squared and we've got take away 25. The difference is the takeaway sign. So we can write this one as x plus 5 and x take away 5. And that pattern where we've got no x term in the middle there should be getting really, really familiar. So we're not done yet because we've just factorized. We still have to find the two x values. So either x plus 5 equals 0 or x minus 5 equals 0. X is equal to negative 5 or x is equal to 5. Okay, so that's my final answer for that one. What have I got left? Two more to go. I think I said I'd go to question 11. Oh yeah, now these two get just a little bit trickier. So this one is a linear inequation or inequality. It's linear because the highest power in here is an x, right? There's no x squareds. If it had x squareds, it would be a quadratic inequality, and they're a little bit of a step up. I'll get to those in video 3. But if it's a linear inequation, you can go watch my video on those where I go through a bunch of them. The big thing we have to watch out for when we've got linear or any kind of inequation is when we're multiplying or dividing by a negative, we have to switch over the sign, right? So in this video, I'm just going to do this problem because I want to get on and get through the worksheet. But this is an area where lots of you are going to have to do quite a bit of practice in the next couple of weeks. But that's okay, we have heaps of time left. So we have 7 times 4 plus x. So first when you see that, just don't worry about this thing here being like all funny. Just treat it like an equals sign and think, well, what would I do first? Well, the first thing we'd probably do is expand. So we get 6x minus 15 is less than or equal to 28 plus 7x. So now I've got x on both sides, so I'm going to do x's to this side, numbers to this side, and off we go. Remember, when I'm doing this step, I'm just adding or subtracting x's and numbers. So I'm not changing the ordering around, so I don't have to worry about this thing switching. Okay, so first I'm going to take 7x from both sides. So I get 6x minus 7x minus 15 is less than or equal to 28. Cleaning that up gives me negative x minus 15 is less than or equal to 28. Next, I'm going to add 15 onto both sides. Negative x is less than or equal to 43. Now, if negative of the number is less than or equal to 43, when I get x and 43, I'm going to divide by negative 1, right? That's what I'm doing. I've got a negative here, and so I'm going to divide by that. When I divide by a negative, I'm going to have x is greater than or equal to negative 43. Let's just think about what's going on the number line here. So if we've got, here's 43 on my number line, and we've got negative x is less than or equal to 43. So we want the negative of the number to be lower than that. So let's think for a minute. If I pick 1, is that going to work? Well, yes, it is, because negative of 1 is less than 43. What about if I pick 45? Is negative 45 less than 43? Yes, it is. What if I pick negative 45? If I do the negative of that, then I get positive 45, and that is not less than 43. So it's worth always doing some checking to see what's happening. Okay, so our solution here is that x has to be greater than or equal to negative 43, because when I did this last step, I actually divided by negative 1. All right, one more question, and it's a harder quadratic one. Okay, 3x squared plus 10x take away 8 equals 0. And these are in the harder video that I posted last weekend called Factorizing by Grouping. The first thing to look at here is that we've got a quadratic, but painfully we've got one where this coefficient, which we call a, is equal to 3. Right? We can write any quadratic in the form ax squared plus bx plus c equals 0. And when we start out, we do all of our work with a equals 1. But now we're starting to get up to some harder ones. So my job is to write it into 2 brackets. And then once we've factorized, we'll figure out what makes these 2 brackets, these 2 factors, 0. So you can do this by doing guess and check. And I'm going to show you that way first now. So we'll put 3x here and 3x here, and then we want 2 numbers that are going to times to give me negative 8. But when I do my expanding, I need to get plus 10x. So if we try 8 and 1, you can see that it's not going to work because we're going to have something 8 here, and we're going to have something with the 3 here. Okay, so that looks like it's not going to be a go. So with guess and check, you can list out your factors. You could list out 8 and 1, and you're going to have a plus and a minus, or we could have minus 8 and plus 1. We could have plus 4 and minus 2, minus 4 and plus 2. But then we have to check all the other way around, right? So it's actually kind of annoying. You'll quickly get fast at seeing what's going to work. But you can see here that I'm listing a whole lot, right? Because the order of the 1 and the 8 matters, and the sign of the 1 and the 8 matters. So some of you will get a feel for what's going to work in here. And when I look at it, I can do this one without doing the grouping method because I've done loads of factorizing in the last 40 years, right? So I look at this and go, well, I think it might work if I try the 3x here and I do a plus here and a minus here. If I do a 4 here and a minus 2 here, let's just see if that works. And this is not me cheating by doing it ahead of time, guys. This is me just looking and having a feel for what's going to happen and then going, yep, that's going to work. Right, let's see. We expand it 3x squared minus 2x plus 12x. So that's giving me my plus 10x, my minus 8. Right, so that's great. And then we can go on and we say 3x minus 2 equals 0, 3x equals 2, x equals 2/3, or x plus 4 equals 0, x equals negative 4, and we're done, right? But I want to show you the other way to do it, which is if your brain freezes and you can't see how to do the split. So when we do grouping, it goes like this. Right, if you're having trouble with everything else in the practice sheet, please do not spend time watching this. This is kind of icing on the cake stuff. Right, the way we do it is we say we want to choose 2 numbers, and the thing that's quite funky is that we want them to multiply to give me negative 24, right? So this number and this number multiplied together are what we're looking at. And then we want those numbers to add to give me this middle coefficient. So we times those ones together and then we add this one. What it does is it's going to give us a way that will break this up so that we can basically do the grid method backwards on it, right? But it's quite hard to show you in this video why it's all going to work. So in here, we're going to have 12 here and negative 2 here, and 12 here and negative 2 here, right? And that will give me 3x squared plus 12x minus 2x minus 8 equals 0. I'm running out of time, and I get this, and I've run out of time. I'm sorry, guys. I'll finish this in video 3. Oh, apparently I haven't run out of time. Okay, so again, we get to this step here. And that's pretty cool. They must have extended the time limit. We get x equals 2/3 or x equals -4, right? But the hard bit when you start doing grouping is just getting the hang of these steps here, which is how we split up that 10x term. Thanks for watching. That was way longer than I expected. I'll be back with the last video in about half an hour when I've done the dishes.